Hello everyone, my name is Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problems of Weekly Coding Contest 139. First of all, let us start with question number 1. What does question say? Valid strings is the name of the question, and it says that you are given an array of n strings. So we have an array which contains n strings, which consist of lowercase English alphabets. So the strings contains only lowercase English alphabets, and an integer k is also given. Find the number of valid strings in this array. Okay, a string is called valid if it contains exactly k vowels. Okay, so what does it say? We are given an array of n strings and we need to tell how many of these strings are valid. Now what is a valid string? If a string contains exactly k vowels, what are vowels? A, E, I, O, U. Okay, and here there are only lowercase letters. So if a small a, small e, small I, small o, yeah, or and small u, any of these are present, it is called a vowel. So if a string contains exactly k number of vowels, then it is a valid string, and we need to tell how many valid strings are present in the given array. For example, if my array contains 4 strings and if k is 2, then here we have E and O, we have 2 vowels. Then here we have only A, here we have O and E, here also we have 2 vowels, and here we have only A and I. Okay, so here also there are 2 vowels. So we have 1, 2 and 3 strings which contains 2 vowels. So the answer is 3. Remember, we need exactly k vowels, not more than that or not less than that. Okay, similarly you can have a look at the second example. You don't need to read input or print anything. Your task is to complete the function valid strings, which takes 2 integers n and k and an array of strings. This function should return an integer representing number of valid strings. Now see, the question is quite straightforward. What we will basically do is, we will take a answer variable initialized with 0. We will loop over the string, and while looping over the string, for the ith string, we will loop over all its characters and count the number of vowels. If the ith string contains exactly k number of vowels, we will say answer plus plus, otherwise we will move on to I plus 1th string. Okay, let's look at the implementation directly. Okay, so let's look at the implementation here. So what I have done is, I have taken an answer variable, I have traversed through the string, I have taken m as the length of the ith string and one counter variable to count the number of vowels in the ith string. Then I have traversed through the ith string, and if the jth character in the ith string is a vowel, I'll increment count. Okay, what does this C variable indicate? It indicates the number of vowels in the ith string. If my count is equals to k, then I will increment my answer and finally return the number of answers. And this my vowel function takes a character a, and if it is either a, e, I, o, u, then it returns true, otherwise it will return false. What will be the time complexity? It will be big O of sum of length of strings. Okay, because we are traversing over all the strings character by character. Okay, and there is no auxiliary space, so auxiliary space will be constant. Now let's move on to the next question. So now let's look at question number 2, that is maximum battalions. What does question say? It says that Geek has the names of n soldiers represented as names. So basically they are given as strings. He wants to divide them into battalions without changing the order of names. So now he wants to divide these soldiers into some battalions, but without changing the order of names. So he will not rearrange the array of n soldiers which are given. Okay. The general will validate the division only if every soldier who has the same name belongs to the same battalion. So what does this mean? That the division should be such that all the soldiers who belong to the same name must be in the same battalion. Okay, and here basically they want to divide the soldiers into continuous battalions. Okay, so they will be divided based on sub arrays. So let's say if there is a soldier with name A, then all the soldiers with name A should belong to one sub array only. Okay, we'll see the example, it will become more clear. Return the maximum number of battalions Geek could make. Okay, so we need to tell how many maximum battalions Geek can make. Also, how do we know that these will be divided into sub arrays? Because here it is said that he wants to divide battalions without changing the order of names. Okay, so they do not want to change the order of names. Okay, so they will be together only. So for example, for n equals to 4, there are 4 soldiers with name ABC, DEF, ABC and AIEH. Okay. Now ABC and ABC must belong in one battalion only. So we need to keep first, second and third soldier in one battalion only. DEF will also be with them because ABC, both the soldiers should be in one battalion only. So that will be one battalion and AIEH will be second. Obviously, you can keep all the 4 in one also, but we want to find maximum number of battalions that could be made. So we will keep first 3 in one battalion and the last one in another battalion. So the output will be 2. Here, if you see here QW, IWERO, ADF, BK and QW. These are the name of the soldiers. Now QW and QW must be in one battalion only. So because of that, the second, third and fourth soldier also we need to keep in the same battalion. So there will be only one battalion. Okay. You don't need to read input or print anything. You only need to complete the function maximum battalions that takes an integer n and an array names of size n as input and returns the maximum number of battalions that can be formed. And the constraints are given here. So now if we think about solving this problem, then first of all, let us take this example where we are given this array. These are the soldiers' name. Now what we want to do is we want to divide them into battalions. And how will we divide them? We will basically, make sub-arrays. Okay, so for example, if this is my array, then this is the first battalion, this is the second battalion, this is the third battalion, this is the fourth battalion, and so on. Also, what we want is that all the soldiers with a particular name, all the soldiers with a given name must belong in the same battalion. For example, AB and AB must belong to the same battalion. Okay. So, how many maximum battalions can be formed? That is the question. So, if I look here, let's say I include AB in my first battalion. Now, another AB is here. So, no matter what is in between, I need to take at least my battalion till here to include this AB also. Okay. Now, as soon as I do this, CD is included and another CD is here. Now, I need to include this CD in this battalion only. Are you getting my point? For example, we started with AB and now because AB is taken in this battalion, we also need to take this AB. But we need to take in continuous form only. We cannot rearrange. That's why CD is also included to this battalion. Now, as soon as this CD is included, we need to include this CD also. So this much is the first battalion. Okay. Now there is no name AB or CD further. So we can stop here. Obviously, you can take all the names in one battalion also. But since we want to find maximum number of battalions, so we will stop here. So this is your first battalion. Now EF is taken in second battalion and there is EF here also. So we need to take these two also. Now GH is taken but there is no GH or EF further. So this can be the second battalion. And this can be the third battalion. So the maximum answer is 3. Now, how can we implement it? So what we can do here is, if we want to implement it efficiently, what we can do is we can, store the last indexes of every string. For example, this is index 0, 1, 2, 3, 4, 5, 6, and 7. So the last index of AB is what? It is 2. Last index of CD is 3. Last index of EF is 6 and last index of XY is 7. Okay. Now, I want that, now what I will do is I will start allocating soldiers to battalions. So, let's say this is my first battalion in which I included AB. Now, as soon as I include AB, I will see what is the last index of AB. Last index of AB is 2. It means I need to take the elements at least till index 2. Okay. So let me take one variable finish where a battalion can finish, where a battalion can end. And because I took AB, my finish will become 2 because I need to go at least till index 2. So I will traverse till index 2. Now when I come to index 1, I will see that CD is present. Okay. Now what is the last index of CD? It is 3. So now my finish will become 3. Okay. Then I will go to AB and also consider it in my battalion. But its last index is 2. So finish will remain 3 only because 3 is greater than 2. Then I will go to CD. Its last index is also 3. So finish will remain 3 only. Now, if I have last consider the element of the ith index, that is in this case third index, and if my finish variable is also equal to that index, for example, this is 3 and my finish variable is also 3. So in this case, what I will do is I will make counter plus plus, because if my answer variable is equal to the finish, it means I can end one battalion here. Are you getting my point? Now I will again start from here and include it into another battalion EF, and last index of EF is 6. So now my finish will become 6. I need to go till at least index 6. So then I will include GH also in this battalion. Its last index is what? GH's last index is 5 only. So finish is 6. This is 5. 6 is greater than 5. So 6 will remain 6 only. Then I will go to this EF. Now this is at index 6 and the finish is also 6. So I will include it in the current battalion, and since 6 index is equal to the finish value, I will say answer plus plus, and hence my answer will become 2. It became 1 year and here it will become 2. Then I will include XY in my third battalion, and my finish will become the last index of XY. Last index of XY is 7, which is equal to this index only. So I will finish here also. So here also one battalion will get over, and my number of I will again do answer plus plus, and my answer will become 3, and finally I will return 3. So this is how we will do maximum number of battalions. Now let's look at its actual implementation. So if we look at the actual implementation, so we have n, that is the number of soldiers, and a vector of strings which gives the names of the soldiers. I have taken one unordered map which will map a string with an integer. Basically for all the names I will store their last occurring index. Okay. Initially my answer variable is 0, and I will start looping from I equals to 0 to end. First of all, I will assign the ending index in my unordered map for all the names. So if names of I is not present in my end map, that is this name of the soldier has occurred for the first time. That is, if end dot find names of I, that is find this name in the end map is equals to end dot end. It means it is not present. Then I will say last occurring index of names of I is I. Else I will say last occurring index of names of I is I. For example, there is a particular name AB which has first occurred at index 2, then it will be assigned 2. Now it is again occurred at index 5, so it will be assigned index 5 at this line. Okay. So by the end of line 48, for all the names, different names, their last occurring indexes will be assigned. Then I will take finish equal to 0, and I will traverse the array, and I will say finish is equal to max of current finish value that I have, or the last occurring index of the current name index. Okay. So whichever is greater, that value will be assigned to finish, and if finish equals to the current index, we can end one battalion here, and I will say answer plus plus. Okay. And then finally I will return the answer. And what would be the time complexity for this? It would be big O of n, assuming that this unordered map on an average takes big O of 1 time to assign these values. So we will say that it will be completed in big O of n time. Okay. Now let's submit it. Let me submit it. Okay, so we have solved this question successfully. Now let's move on to the next question. So now let's look at the solution of the third question, that is maximum energy. First of all, let us start by understanding the question. What does it say? Given an energy array E of length n, where E of I represents the total unit of energy present at the ith index of E. Okay, so E array represents energy and E of I gives me the energy at the ith index. You are also given an array P of length K, where K is even. Okay. You have initial total energy as 0. So initially the energy is 0. You have to perform the following operation exactly K by 2 times. Okay. What are the operations? First is to choose two distinct indexes I and J such that 0 is less than equal to I, is less than equal to J, is less than length of P. Okay. P contains how many elements? K. So it must be less than K. Okay. Second, if P of I is less than equal to P of J, increase the total energy by the sum of elements of the subarray Pi to Pj, else increase the total energy by the sum of elements of the subarray Pj to Pi. Basically, if Pj is less than Pi, then just swap Pi and Pj, or you can say for a particular Pi and Pj, if Pi is less than equal to Pj, and if these two we count them as indexes, then from the energy array, we need to return the sum of elements of this subarray from Pi to Pj. Otherwise, we need to return the sum of the subarray from Pj to Pi from the energy array. Okay. And the third step is remove the elements Pi and Pj from array P. So we cannot repeat the elements from array P. Find the maximum total energy you get after performing the operations modulo 10 to the power 9 plus 7. It might be you might have a little bit of doubt in the question, but we'll understand with an example. It will be very clear. Okay. For example, now I will explain you with the help of this example. So I'm not taking the example right now. Okay. You don't need to read input or print anything. Your task is to complete the function maximum energy, which takes the two integers n and k and two integers e and p and returns an integer denoting the maximum total energy you can get after performing the operations modulo 10 to the power 9 plus 7, and the constraints are given here. So now in order to solve this problem, first of all, let us understand with this problem better with the help of an example. Okay. So we are given n equals to 5 elements, which is the number of elements in my energy array, and k equals to 4, that is the number of elements in my p array. Now k is always even. Okay. Also the value of p arrays is between 0 and n minus 1. So the elements in my p array can act as valid indexes for my energy array. Okay. Now what they are saying is we need to perform an operation exactly k by 2 times. Okay. What does this operation say? Pick any two elements from the p array. Let's say I picked this and this. Okay. So my ith element is 3 and jth element is 0. If p of I is greater than p of j, here it is the case, p of j is less. So I need to add the elements which are represented by the subarray 0 to 3 from the energy array E. So from the energy array, the subarray which represents these elements, I need to add the value of these elements to my answer array. So my 0 index is this and third index is this. So what is the sum of elements of these indexes? It is 9 and 10, 19. 19 and 5 is 24 and 2, 26. So I will take 26 in my answer. Then I will remove these two elements. So one operation is done. Now there are total 4 elements, k by 2. 4 by 2 is 2. So I need to perform 2 operations. Now I will perform operation on this and this. Again, this is less than this. So what I will do is I will take p of this is what 1. This index is what actually 3 and this is 0. So p of 3 to p of 0. Now what does this represent? P of 3 is 1 and p of 0 is 2. So from 1 to 2, the subarray from 1 to 2 represents 5 and 10, 15. Okay, so I will add 15 to my answer and I will get 41 as the result. Okay, and now this p array is empty. Here I will stop and I will return 41. Now if in case the values which I selected pi and pj, suppose I selected this is my ith element and this is my jth element, then pi is less than pj, then because p of I is 2 and p of j is 3. So in this case what I will do, I will take the sum of elements of the subarray from pi to pj. Okay, and here it will be 2 plus 3, 5, and I will add 5 to my answer. Then I will remove these two elements and proceed further. Okay, you got my point. So basically there are k elements in the array P which can represent valid indexes of the energy array, and I need to perform k by 2 operations on the array P. In every operation I will select 2 elements, and whatever subarray that 2 elements represents in my energy array, that subarray sum I will add it to my answer. There can be multiple possibilities. Now among the multiple possibilities, I want to find the maximum answer possibility. Okay, I want to return the maximum sum. Also, no two elements from the P array can be picked again. Not even a single element can be repeated, because as soon as you pick 2 elements, you will remove those 2 elements before moving on to the next operation. Now how can we maximize it? So see here, my P array represents indexes of my E array. So if I pick 2 elements from the P array, it will basically represent a sub array. Okay, so see, let me give you an example. Suppose this is my E energy array, all the values are positive, right? Now let's say I have pi, pj, pk and pm. Okay, I have 4 indexes in my P array. Okay, now one possibility is I choose this as 1 and this as 1. So what will happen in that case? This many elements will be taken and this many elements will be taken. Okay, another possibility is I take pi and pk as one pair I take Pi and Pk as one pair, so these elements will be taken, and Pj and Pm as another pair. Okay, so these elements will be taken. Are you getting my point? So here what was coming here that is already coming, but the center part is coming twice, so this is giving me more sum, right? Why it is happening? Because if when I take Pj, Pm and Pi, Pk, this is the overlapping part of two subarrays, so that is coming twice. Whereas when I was taking Pi, Pj and Pk, Pm, this part was not coming in any of them, so this is better. Another option could be I can take Pj, Pk and Pi, Pm. Okay, so if I take Pi and Pm as one pair, then this complete array will be taken, and another would be Pj and Pk. So again these many elements will be repeated. Now these two are same in this case. Are you getting my point? So we need to select the indexes in such a way that maximum overlapping is there and maximum repetition of elements is there. We do not want to select such indexes like Pi, Pj and Pk, Pm. Are you getting my point? So how can we select here? See, here the optimal way to select the sub arrays would be if this is my energy array and if these are the indexes P1, P2, P3, P4, P5, let's say, or P6. Okay, let's say these are the 6 indexes. So I will take P1 and P6 as pair, so I can get this much part. Then I will take P2 and P5 as another pair, so I can get this much part. Then I will take P3 and P4 as pair, so I can get this much part. So maximum overlapping is there. Okay, so how can we solve this problem? We will first sort all the elements of my P array. Okay, and then we will take the first element and the last element, then take the sum of that subarray and add it to the answer. Then take second element and second last element and take the sum of the subarray represented by that and add it to the answer. And we will do this process for k by 2 times until our P array becomes empty. Whenever we do an operation, we ideally need to remove them from the array. Okay, basically we cannot repeat them. Okay, so let's try it on this. So my P array is 2301. So first of all short it, so it becomes 0123. Now take the sum of the subarray representing 0 to 3. It is what? 26. We solved it, right? It is 26 from 0 to 3. Another is 1 to 2, so that is 15. So add 15, this will give you 41. This is the maximum answer which you can get because you are taking the indexes such that maximum overlapping is there. Also you need to add subarray sum every time. Okay, for k by 2 operations. So what you can do is you can initially take a prefix sum of your energy array, so that every time you want a subarray sum you can do it in one step only. Now let's look at its actual implementation. So if we look at the actual implementation, so we have answer variable as 0, a sum variable, some other variables, and mod equals to 10 to the power 9 plus 7. First of all, I have taken the prefix sum for my energy array and every time taken the mod value. Then I have sorted my P array, which basically represent indexes. Then for k by 2 operations, I need to select the first element, ith element of the, for example, if this is my P array, then ith element would be paired up with k minus I minus 1th element, right? So first index of the subarray, let's say the subarray is represented, this is my energy array and the subarray is represented with indexes I1 and I2. Then I1 will be P of I and I2 will be P of k minus I minus 1. Now if I1 is greater than I2, then I will swap. But actually this step shouldn't have been added. Even without this it would work because we are sorting the array here. Okay, so probably this step is an extra step. Then I will take the prefix sum represented by I1 to I2. So sum is equals to I2, and if I1 is greater than 0, then only remove the sum till I1, prefix sum till I1 minus 1. Okay, and since we are taking mod, so plus mod modulo mod, and add this sum value to my answer. Okay, and take mod, and finally we will return the answer. What would be the time complexity? First of all, this will take a for loop of size n. Then this sorting will take the time of k log k because there are k elements, and then a for loop of size k. Okay, so basically the time complexity would be big O of n plus k log k. And what would be the auxiliary extra space required here? Here we are not taking any extra space, we are only taking a few variables here, so the auxiliary space would be constant. Okay, I hope you have understood this third question completely. Now let's move on to the last question. So now let's look at the last question, that is possible strings. What does question say? You are given two integers n and k. You have to find total number of strings of length n which satisfies the following conditions. Okay, so we need to find total number of strings of length n which will satisfy the given two conditions. String only contains lowercase English characters, okay, and second is no k consecutive characters of the string are same, okay. So for example, if k is equal to 3, then no 3 or more characters consecutive of the string must be same, okay. When they say no k consecutive characters should be same, it also implies no k plus 1, no k plus 2 or any value greater than equal to k consecutive character must be same. We need to return the answer taking modulo 10 to the power 9 plus 7. For example, if n is 2 and k is 2, total there will be 650 different values. For n equals to 3 and k equals to 3, there will be this many different values, okay. You don't need to read input or print anything. Your task is to complete the function possible strings, which takes two integers n and k, and return the total number of strings of length n which satisfies the condition. And the constraints are given here. So now if we think about solving this problem, then basically we are given two values n and k in the input, and we need to find the total number of strings of length n such that greater than equal to k consecutive characters cannot be same. Okay, this is the condition, and we need total length of the string must be n. So how many such strings are there that we need to tell? For example, if n equals to 2 and k equals to 2, it means no two consecutive characters can be same. Okay, so at the first position you can take any of the 26 characters, but at the second position you cannot take all 26 characters, because whatever character is taken here, let's say here a is taken, so here you cannot take a. So here you will have 25 choices. Whatever is there on the first position, you cannot take it here. So it will be 26 into 25. That would be how much? That will give you 650. That was the answer. Okay. So how can we solve this problem? Now you see here the value of n can go up to 10 to the power 5, and the value of k can also go up to 10 to the power 5. Okay. And total different distinct characters can be how much? 26, because it is said in the question that we can use only lowercase English alphabets, right? So now how can we do this? So you see here what we can do is first of all, the most basic way is by recursion. Okay. So what we can do is, using recursion, we can call a recursive function. Let's say this is the position which I want to fill, okay, or let me put it 1. So this position will go from 1 to n, and this second character will denote how many consecutive characters have been same. Okay. So for example, if I also take answer string here, or not answer, this will basically denote the generated string, okay, generated number. Okay. So what I will do is, when I am filling the first index, the first position, there can be 26 different choices, right? Okay. Cut this part. Okay. So after 650, continue from here. So now here the value of n and k can go up to 10 to the power 5. Okay, so we need to find the number of strings of length n which contains only lowercase English alphabet. So it will be from small a to small z, and no more than equal to k consecutive characters can be same. Okay, so how can we solve this? See, the most brute force method is what? Recursion, right? Try to generate all the strings, and whatever strings are possible, count them. So I can call a recursion function which will basically first take the index which I want to fill. This will be the last how many consecutive characters are same. And here, let's say I have the string which is generated currently. Okay. If my string, if I am at 0 index, now there can be 26 different possibilities, right? So the recursion will now go to index 1. Okay. Now if we try and fill the first index, the last consecutive one character is same, and the string can be A, or recursion 1, 1B, or 1, 1C up to recursion now try to fill the first index, last one consecutive character is same and the last string generated is Z. Now at the first index also I can have 26 different possibilities, right? So if I take A again here, then it will become recursion. Now fill the second index, number of consecutive characters same are 2 and the string generated is AA. But let's say if I took B here, then it will be recursion 2. The number of consecutive characters will become again 1. Okay. Why? Because the string generated is AB. So there is only one last consecutive character which is same. Here there are 2, right? And so on. We can generate all the possible recursions. What will be the base cases, or when will we stop? When our I, that is the index we are trying to fill, becomes equal to n, we will return 1, that this is one possible string. That is one base case. So if I becomes equals to n, we will say return 1 because we have reached the end and this is one possible string. What can be the other stopping conditions? If the number of consecutive characters, okay, so I need to first check that if let's say this is the value is consecutive, the second value is consecutive, this is my index I and this is the string generated. So if number of consecutive characters have become equal to k, the last k characters have been same, then I will return 0. I will not go further irrespective of whether my string is completed or not. If that is not the case, and if my string is completed, so if I equals to n, then I will say I have generated a valid string, I will return 1. Okay. And if this is also not the case, then what I will do from for j equals to 0 to 26, I will try to assign a 1 by 1 each different character at the ith position and further call the recursion. Okay. And if it is the same character at I minus 1, then the consecutive variable will become +1. Otherwise, it will start from 1 again. Okay. And the string generated will be attached. Okay. I think we can also, here instead of string, we can also just pass the last character taken, because we just want to see whether the number of consecutive character increases or not. So there is no need to pass the complete string. We can take only the last character. But this brute force approach will approximately take how much time? Approximately, there will be 26 choices for all the conditions, right? And there are n positions. So it will be 26 ki power n, and this will be a very big. Okay, so we need to return something more efficient. We need to do something more efficient. Now, whenever there is a polynomial, whenever there is an exponential time complexity, which we want to convert it into polynomial, we can think of dynamic programming, right? So now let's think whether we can convert this problem into dynamic programming or not. So for that, we need to see overlapping subproblems. Are you getting my point? So how can we see overlapping subproblems? So for that, what we can do is, you see here, there will be overlapping subproblems. How? Yeah, so what I can say is, if the first, let's say some characters, if there are here the last k minus 1 characters are a. Now here there will be many different values possible, right? Let's say this is a string which we are trying to fill. Here there will be many different values. But irrespective of that value, here I will have 25 choices, because if last k minus 1 characters are a, then here I can fill what? Anything from B to Z. So whatever be the value here for this many characters, so for this will be the same problem for all of that. Are you getting my point? So this, when I will call recursion here, I want to find the number of strings possible such that the last k minus 1 characters are a. So this will be the repetition. In fact, whenever we are trying to find the number of, for example, if my recursion call has reached index I want to find the number of strings possible such that depending upon the characters which we place from index I to n minus 1, how many different strings are possible, and from 0 to I minus 1, some characters are placed, right? Now in this also, last how many consecutive characters are common, that will only matter. Are you getting my point? For example, here 3 characters are common, then irrespective of what the value here is, this count will be same for that. For example, here 4 characters are consecutive are common, then irrespective of what the value here is, here or this count will be common for them. Are you getting my point? So this value we will be counting again and again depending upon last how many consecutive characters are same, right? Irrespective of what the values are first. So we will get overlapping recursive calls. So we can think of dynamic programming. Now, how can we think of dynamic programming? You see here, let's say this is my, so I am trying to solve this with the help of tabulation. Okay, so I will fill the table and then return the answer. So let's take a general case and then we will fill the complete table. So for example, I will take a DP table of size n plus 1, where DP of n will denote the number of strings of length n such that no more than equal to k consecutive characters are same. Okay. So let's say from 0 till I have filled. Okay. So I have DP of I value with me. And now I want to find DP of I plus 1. Okay. So you see here, can I say dp of I plus 1 is equals to dp of I into 26? Because here there are 26 possibilities from small a to small z, right? Minus, now I don't want 26k consecutive characters to be same. Now you look here, if I have calculated dp of I, it is giving me the number of strings of length I such that no greater than equal to k consecutive characters are same. So, at most, the maximum number of consecutive characters ending at index I would be how much? K minus 1. In this count, let's say dp of I is equals to 500. So, these are the number of strings of length I such that no greater than equal to k consecutive characters are same. So, among these 500 strings, the maximum number of consecutive characters ending at index I would be k minus 1. At max, right? So for these strings where the last k minus 1 characters are same, I cannot repeat the same character here. Okay, so that's why this dp of I into 26 will also contain the strings which will have last k consecutive characters same. So I need to subtract them. So what will be the count of that? Are you getting my point? This dp of I will contain some strings which have k minus 1 consecutive characters at max. Now, when I do multiply by 26, I am considering all choices. So, this will also contain the strings which will have 26 consecutive characters. There cannot be more than that. Because till I, it can have at max k consecutive characters, not 26. Because till I, at max k minus 1 consecutive characters were present. Okay, not more than k consecutive characters can be present in this count. So dp of I into 26. Now from this, I need to subtract the strings which will have last 26 characters count same. So from I plus 1, if I remove the last k consecutive characters same, not 26. I am using the word 26 instead of k multiple times, but I am talking about k consecutive characters. So I don't want last k consecutive characters to be same, which are counted for some strings here. So what I will say, if I move k characters aside, I want to find the last k consecutive characters same, how many strings are there. So if I move k positions to the left, what will be the index here? It will be I plus 1 minus k. So dp of I plus 1 minus k will give me the number of strings of length I plus 1 minus k such that no more than equal to k consecutive characters are same. And what I said, here all k consecutive characters are same. So how many different values can be present here? So what I can say is dp of I plus 1 minus k into 25. This much strings I would subtract. Now why this? Because you look here, dp of I into 26. dp of I is number of strings of length I where greater than equal to k consecutive characters are not present. I multiplied it by 26, so I took all possible cases, right? But there might be some strings ending at index I where last k minus 1 characters are same. If the last k there cannot be more than that, right? Because there cannot be k consecutive characters in dp of I, which is already calculated. So these k minus 1 consecutive characters are same. So what I did was, I need to, when I take here into 26, I am taking all the possibilities. But I need to subtract the count of strings in which all these k characters are coming same. Now, what will be the count of that? That would be dp of I plus 1 minus k. That is the number of strings of length I plus 1 minus k whose in which greater than equal to k consecutive strings are not present, multiplied by here how many different possibilities are there for all k characters to be same. It is 25, not 26. Why? Because see, here I said there are k minus 1 consecutive characters same. It means, let's say here all of them are A. It means this position cannot be A. Are you getting my point? If all of them here are B, this position cannot be B. Are you getting my point? So if this position contains P, then for this k minus 1 consecutive characters which are same, which we assumed, it cannot contain P. So it can contain 25 characters only. So in order to make all these k consecutive characters same, I need to choose one of the 25 characters. Are you getting my point? Your till index I, there might be some string where the last k minus 1 characters are same. Now, if these are k minus 1 characters same, it cannot be more than k minus 1, right? So these k minus 1 characters which are being repeated cannot be same as this previous character. If this character is P, here it cannot be P, right? So I am subtracting the count of strings ending at index I plus 1 where there are k consecutive characters, because we do not want that. So how many total possibilities are there for these k consecutive characters to be same? Place all the k characters with A or with B or with C up to all with Z. But you cannot place it with P, because otherwise it will become k plus 1 consecutive characters, which is not present only, right? Because those characters which are present k minus 1 times can be converted into k times. That's why dp of I into 26, all possible cases, minus dp of I plus 1 minus k. That is how many total different variety of strings are possible till here. And in all these k characters, you will place the same character. So multiply by 25, not 26. Why? Because this character cannot be taken. So this is the general equation. Now, how will you fill the dp table? First of all, dp of 1 will be 26. If there is only one character, there are 26 choices. Now till k minus 1, what you can do for I equals to 2, I is less than k, I plus plus. If the length is only less than k, then you can place anything. So dp of I is dp of I minus 1 into 26, all possibilities, right? Now for dp of k, you can say it is equal to dp of k minus 1 into 26, all possibilities, minus you need to subtract the count of strings where all k characters are same. So if all k characters are same and the length of the string is also k, which is we are considering, there can be 26 different choices. Either all are A, or all are B, all are C, and so on. So minus 26. And from k plus 1 onwards, for I equals to k plus 1, I is less than equal to n, I plus plus, you can say the equation which we derived, okay, dp of I equals to dp of I minus 1 into 26 minus dp of I minus k into 25, okay, and this will give you the answer, right? Here it was I plus 1, so it was I into 26 and I plus 1 minus k. Here it is I and I minus 1, so this will be I minus k into 25, but the logic will remain same. And finally, you can return dp of n, which will give you the number of strings of length n possible, such that there are only lowercase English characters and no more than equal to k consecutive characters are same. Now let's look at the actual code and submit it. So if we look at the actual code, so I have taken the mod value, I have taken ij and a variable same, which I have used for some previous implementation, but that is not useful. I will take k if k is 1. If k is 1, it means no one consecutive character can be same. It means there is no possibility. So I will directly return 0. Then I will form the dp table. dp of 1 is 26. This is as I explained. This also I explained the equation, how it comes. Then this also I explained, right? And finally, I will return dp of n. And how much time this will take? It will take big O of n time. Let's submit it. Oh, there is an error. Let's see what the error is. I don't think you should get any error. I think the error is because, maybe because, let's take this value to be 10 to the power 5. Okay. Now let's try to submit it. Okay, so we have solved this question successfully. I hope you understood the solution of this and all the 4 questions properly. Okay, thank you.